I guess I'm going to talk about, first of all, data science rule number 0, which is know your domain. So there are 500 million small-scale farms around the world, and our job at Wefarm is to connect every farmer. And that's to the advice, services, products, and information and markets that they need to grow their businesses. So that's a lot of people, and many of them live in places like this: remote, rural, isolated, miles, hours, days from the nearest center of commerce, place where you can buy your inputs and sell your produce. For these people, Wefarm provides connection. So meet Victor. Victor's a farmer. He grows tea, and he discovers one day that there's a fly on his crop that he's never seen before. He doesn't know what to do. He's not got anyone to turn to. The nearest source of advice, again, maybe days away. On the other hand, here's Doris. Doris lives the other side of Kenya. She's been dealing with that same pest for many years. She knows exactly how to treat it. And Wefarm enables Doris and Victor to connect, for Doris to give Victor peer-sourced, useful information that Victor can use to solve his problems. And that's all via SMS, and in multiple languages, many of which most NLP tools don't cover, or any NLP tools don't cover. So that's English, Swahili, fine, Luganda, Runyakitara. Yeah, and it's all via SMS, which is an amazing opportunity. Farmers have phones. They may not have the latest iPhone X, but they will have a phone. They will have, it may be a dumb phone, it may be like this, it may have broken keys, but they have a phone. And they use that phone to do their day-to-day business, to stay in contact. And that phone gives Wefarm an edge, a connection to that farmer, and an ability to talk to them. But I don't know if anybody's ever used SMS data before. This is all you get. You get text, you get the text of the message, you get a phone number, and you get a timestamp, and that is it. So that really leads me on to where I started this presentation, is doing data science in languages that I don't understand. So we need to pick everything out of that message in order to connect these farmers. So first of all, is Victor asking a question? Well, first of all, what language is Victor talking? Is he asking a question? Is that question spam or not spam? What's that question about? Who should we then send that question to? Who do we know about in our system who has answered questions that are similar to that before? And really, that's the sort of challenges that we're facing on Wefarm. These are the sort of challenges that we've made some stab at. We're also now developing other solutions to other problems about getting inputs, finding the people who really need access to good quality fertilizers and giving them access to that, and then someday in the future give them access to an output market as well. So our pipeline looks a little bit like this. So Victor's message comes into us with these 3 elements: content, phone number, and timestamp. It goes through our machine learning, which is written in Clojure if anyone's interested. So that's all Bayesian at the moment. I'm looking to improve the quality of those models and improve them to make the language detection even better, the content detection even better, to really pick out the nuance of the messages that we receive. And then ultimately identify that Doris may be a really good candidate for receiving that question. And obviously I don't have enough time to go through all of these elements today, but I just wanted to pick out one. Just wanted to quickly talk about language detection. And the way we do language detection at Wefarm is like this. So it's Bayesian. What we do is pick out the trigrams of a message. So if the word is when, first of all we pad it, and then we pick out the permutations of 3 letters in a row. So in this case it'd be space W, space WH, WHE, and so on. Then we compare that to known frequencies of those trigrams from other languages, and ultimately we can determine whether this word looks more like English or like, say, Swahili. And you tend to find something like English has lots of THs and WHs, and Swahili has lots of KWs and MBs. And this works really well. Just want to test you. So anyone want to guess what language this is?
Polish.
I heard a couple of Swahili. Well, it's not. But it does look like Swahili. So one of the great things about a Bayesian model for language detection is you can run it in reverse. And you can generate a string of text that looks like a Swahili message, even though it's completely gibberish. You can do the same thing for English, but it's much more obvious. But the interesting thing is you can then run this through, say, Google Translate. And Google's clearly doing something similar to we are in terms of language detection, so immediately identifies this as Swahili. But then clearly is doing something more complicated when it comes to the translation step, because you actually get English out, even though this is a meaningless input. So, just be careful with Google Translate is what I'll say. It's quite nice. So, clearly there's issues in terms of doing machine translation. Clearly there's issues in terms of doing all of this over such small data. But Wefarm has one big advantage. And I think that's really the fact that we try and use artificial intelligence to enable human intelligence. So yes, we can detect something looks like English. Yes, we can detect we think it's a question. Yes, we can detect that we think that's a question about maize. But fundamentally, we then have the opportunity to send that to somebody. Our model is about sending questions to people and getting peer-sourced information. So every end of our chain has somebody on the other end. It's about routing. It's about identifying the people who are best able to help each other. And so even though I dislike the term artificial intelligence, I really like this way of putting it. It's about empowering people. And after all, human intelligence is the best form of artificial intelligence that we know. So we're hiring. Please come and talk to me or any of the Data Idols team if you're interested. We're looking for a lead machine learning engineer. So we've got a lot of Bayesian models, and I'm looking to really improve them, put some better pipelines in place, and figure out whether neural networks, other approaches might give us a better accuracy, and build out other tools and other possibilities for the future as well about connecting people. And yeah, thank you. That's my talk.